this one more time. All right, so 4.3, we've already established it a little bit, all right? So I'm just going to go back to the question that I said earlier, all right? Where we had 5-digit number, okay? And I wanted to pick a 3-digit house number from these 5 digits. So how do I do that? I can use that fundamental counting principle. There was 5 choices, 4 choices, 3 choices, which is equal to 60. Well, there's another way in which we can do this, and it's called permutations. All right? And the symbol for it looks like this, NPR. Now, this is the most important thing that you have to remember for this. For a permutation. For a permutation, order is important. You need to make a note of that because we're going to do combinations next in which order is not important and they're done very similar. So you have to know the difference between the two. That's the hard part. Reading a question and knowing what is a permutation, what is a combination. So a permutation works like this. This is n choose r, or well not choose, but I'm going to select r objects from n amount, and I'm going to order them. I'm going to arrange them. So what does it look like? I go n factorial. Make sure I got this right. Over n minus r factorial. Okay? So I'm going to, this is n is the number of objects I'm selecting from. R is the number I'm choosing. So looking at this particular question that I just asked you. All right? How many do I have to choose from? How many do I have to select from? How many numbers am I working with? How many? 1, 2, 3, 4, 5. 5 factorial. Right? And out of those 5, how many am I choosing? 3. So I go 5 minus 3 factorial, which equals 5 factorial over 2 factorial. Well, what does that mean? 5 times 4 times 3 times 2 times 1 over 2 times 1, right? Cancel, cancel. 5 times 4 times 3. 5 times 4 times 3. 60. Same question can be done using a permutation. Permutations, order is important. Okay? So it has to be very specific. All right, so let's look at a second example here. How many different permutations are there of 5 objects from a set of 7 different objects if repetition is not allowed? Okay, so what am I looking at? 7p5. All right, first thing you're going to do is take out your calculator. You're going to put in number 7. Then you're going to go to math, probability, find NPR. Hit enter, put 5, so it should look like 7 NPR 5 on your calculator, and hit equals, and what do you get?
2,500.
Wrong one. Went the wrong way. What is it?
2,500.
Again, 40?
20.
20. Thanks. Gotta be loud. Very loud. 2,520, right? Okay. So let's look at this. By formula, it means 7 factorial over 7 minus 5 factorial, correct? Right? 7, 6, 5, 4, 3, 2 factorial. 2 factorial cancels. What am I left with? 7 by 6 by 5 by 4 by 3. Which works out to 2,520. So they're going to test your ability to do both. Okay? All right. Last example here. Marta is writing a science fiction story in which the serial number of a starship can have 1, 2, or 3 different letters, followed always by 4 different numerals. How many different starship serial numbers are possible? So she has 1, 2, or 3 different letters, followed always by 4 different numerals. Okay. So there's 3 cases to this. What are the 3 cases? What are they involved? What are the 3 cases involved?
1 letter plus 4 numerals.
Yes.
1 letter plus 4 numerals, and 2 letters plus
100%. Very good, Gabby. So what is it? I have either 1 and 4 numbers, 2 letters, 4 numbers, 3 letters, 4 numbers, right? So looking at the first one then, if I choose 1 letter, how many do I have a choice of?
Say that again?
Choosing 1 letter, how many choices do I have?
4.
How many letters are in the alphabet?
Not 26.
So there's 26 choices, and then I have 4 numerals to choose from how many digits? Gotta include 0. 10. So 10 P4. Okay? So I've got 26 times 10 P4, which is 131,040. Again, calculators are used. Now I've got 2. 2 to choose from. You can do this one of 2 ways. You can put 2 blanks down. All right? First letter, how many choices? 26. Second letter, how many choices? 25. Still 10P4. Correct? 3,276,000. Case 3. 3 letters. So let's do this differently. How many letters am I choosing from? Or how many choices of letters do I have? 26. And how many of those 26 do I need on the last one? 3. 26 P3 times 10 P4 equals 78,624,000. Add those all together, and there is 82,031,450. Again, we've got to work with restrictions first in order to do this. Okay? Permutations and the fundamental counting principle go hand in hand with each other because they're essentially the same thing. All right?